Hello, this is Mrs. Nearing, and I'm going to walk through a sample problem with a balancing redox reaction. And some redox reactions are really straightforward to balance, like the single displacement type, and some are a little bit more complicated. And the ones you can spot that are more complicated are the ones that involve oxoanions, meaning polyatomic ions that involve oxygen, like common ones we've seen are permanganate ion, or oxalate ion, or thiosulfate. So if you see an oxygen-containing polyatomic ion involved in a redox reaction, then you might need to use these steps to balance it. And you'll notice with reactions like this, you won't be able to just balance it by just adding in coefficients. The waters and hydrogen ions need to get involved. So here's a sample problem. Solid iodine is combined with aqueous hypochlorite, forming aqueous iodate ions and chloride ions. So let's write out what that is. So my reactants are iodine and hypochlorite. My products are iodate, excuse me, and chloride. So my first step is to split this reaction into a oxidation and reduction half reactions. And so we can go through and look at your oxidation numbers of all of the elements in here and figure out who is being oxidized and who's being reduced. So if you look at iodine, iodine's in its elemental form right now, so its oxidation state is going to be 0. If you look over here at hypochlorite, I know that oxygen will have a -2 charge, or -2 oxidation state, and chlorine, well, I know that these charges have to add up to -1, so that means chlorine must have a +1 oxidation state in that ion. Over here, again, I know that oxygen tends to be -2. There are 3 of them, so that means I've got 6 negatives total. I need my total charge to add up to -1. That leaves me with iodine having a +5 oxidation state in that polyatomic ion. And then here, right here, we've got monoatomic chlorine ion, so its oxidation state is the same as its charge. So what we'll notice is oxygen's oxidation state is staying the same. So the thing that is being oxidized is my iodine. It's going from 0 to +5. So it's becoming more positive. It is losing electrons. So that's my oxidation half reaction. It looks like my chlorine is going from +1 to -1. So that is a reduction. Reduction means you are gaining electrons. So it's becoming more negative in nature. So I've identified what my oxidation and reduction reactions are. So now I'm going to split them up into what we call half reactions, these kind of skeleton half reactions. So my first one's going to be I2 to IO3 minus. That's my oxidation half reaction. And then OCl to Cl minus. That is my reduction half reaction. And again, what you want to do is you want to go through these steps. I'm looking at my list right here of steps. You can find these in the PowerPoint that we did, Steps to Balancing Redox Reaction. It's also in that review that I posted up on Brightspace. I summarized the steps there as well. You can also look in your textbook. In the Brown book, it's chapter 20. In the Trow book, it's chapter 18. Those have the steps as well in the sample problem. So just follow through the steps. So step 1, split them into half reactions. Step 2, balance the elements other than O and H. So like in this case, I've got 2 iodines here, but only 1 iodine over here. So first step, I want to balance the iodine. So I got to put a 2 there. Down here, my chlorines are good. No coefficients needed for that step. All right, next, balance the O's by adding in waters. So over here, I've got 6 O's on the right. So I'm going to balance out those O's by adding in some waters. Each water contains 1 oxygen, so I need to add 6 waters to make sure I have the same number of oxygens on each side. So you'll notice what happens, what makes these reactions more complicated is waters get involved in the redox reaction, as well as hydrogen ions. Down here, I've got 1 oxygen over here, none on this side, so I'm going to add 1 water over here. Now I've got an oxygen on each side. Okay, so I've balanced my unique elements, I've balanced my iodines and chlorines, then I've balanced my oxygens. Next step, as I go down the list, balance my hydrogens by adding H+ ions. So we're going to assume that this is happening under acidic conditions. Typically it should tell you that in the problem, that this reaction happens in acidic conditions. So that means, so if it's happening in acidic conditions, that means that there are H plus ions floating around, because acids will produce H plus ions. Okay, so we want to balance out the hydrogens by adding H plus ions. So over here on the left, I have 6 times 2, I have 12 hydrogens. So that means on the right, I need to also have 12 hydrogens. So I'm going to put 12 hydrogen ions over here. Down here in this reaction, I've got 2 hydrogens on the right, so I need to have 2 hydrogens on the left. So I'm going to add 2 H plus ions. So again, my steps. Split them into half reactions. Balance the non-O or H elements. Then balance the O's by adding waters. Then balance the H's by adding H pluses. Okay? The next step, balance the charge by adding electrons as needed. This is the part where a lot of people make mistakes when they're tallying up the charges. So over here on the left in this reaction, my charge over here is 0. Over here on the right, my charge is, well, I've got 2 negatives from these 2 ions, and I've got 12 pluses. So my charge on the right is positive 10. My charge on the left is 0. The charge on the left and the right need to stay the same. So charge needs to be conserved. So if it's 0 on the left, it needs to be 0 on the right. The way that I balance that out is by adding electrons. And I want to add the electrons to the side that is more positive. Okay, so I'm going to go over here, and I'm going to add 10 electrons over here on the right. Now I'm going to have 10 positives, 10 negatives. Now my charge here is 0. So now I'm balanced out 0, 0. Okay, let's look at this one. I've got 2 pluses from my 2 H plus ions, and I've got 1 negative from my OCl minus. So that means I have a +1 charge on the left. Over here on the right, I've got a negative and a neutral, so I've got a -1 charge on the right. I can add electrons to balance out the charges, so it looks like in order to balance these out, what I want to do is add 2 electrons over here. So I've just added a -2. Now, this is going to add up to a -1. Over here, I've added 10 electrons, so now this charge is 0. So now my charge on the left equals the charge on the right in both of my half reactions. And right now, we say that these half reactions are balanced. So I have 2 balanced half reactions. Okay. The last step in which you want to do, let me erase these. Actually, one other thing I wanted to point out is notice how in this reaction, the electrons show up on the right. In this reaction, the electrons show up on the left. That always must happen. One reaction must gain electrons while the other one loses electrons. So notice this one's losing electrons. So this is our oxidation half reaction, which matches what we predicted up here. Iodine is being oxidized. So it's losing electrons, so its electrons should show up on the right-hand side. My chlorine is being reduced, so it is gaining electrons. So if electrons show up on the left, that means they're being taken in, and that is a reduction reaction. So one should always gain, the other one should lose. And what's important is that the one reaction needs to gain as much as the other one loses, because electrons have to be transferred from one element to another. So if this iodine is losing 10 electrons, my chlorine half reactions need to gain 10 electrons. So our next step is to multiply by an integer as needed to make sure my electrons gained equals electrons lost. So in this case, what I want to do is I want to take this whole reaction here and I want to multiply it by 5. Okay? So I'm going to take this 5, I'm going to distribute it through. So this is going to turn into 10 electrons. 5 times 2, this is going to turn into 10. This is going to turn into 5, this will be 5, and this will be 5. Okay, so I've multiplied everything by 5. Now my electrons gained equals electrons lost. And my final step is I'm going to add these reactions together. I'm going to add them up, okay? So what that's going to look like is this. Everything on the left, I'm going to write down. So 6 waters, and 1 iodine, and 10 electrons, and 10 hydrogens, and 5 hypochlorites. Okay, that's everything on the left. Then I'm going to go over here, draw my arrow, and take everything on the right. So 2 iodates, 12 H pluses, 10 electrons, 5 chlorides, and 5 waters. And now I want to simplify. Okay, let's see if I can simplify anything that shows up on both sides. So for example, my 10 electrons shows up on both sides. So those are going to cancel out. That should always be the case. Electrons gained should equals electrons lost, so you should never end up with any electrons in your final net equation. Okay. Notice I have 12 hydrogens here and 10 hydrogens over here. So I'm going to simplify that and say, well, really, I just end up with 2 more hydrogens than I start with. Okay. So I'm going to simplify that and turn it into 2 H pluses over here. You can think of it as basically like I subtracted 10 H's from each side. Okay, so I end up with 2 H's here and none over there anymore. I have 6 waters over there, 5 waters over here. So I can simplify that as well by eliminating that and turning this into 1 H2O. So now this looks like kind of a big mess. Okay, so I'm going to take it, let's rewrite it maybe in the space right above what the final answer should be. So I'm going to erase this and let's figure out our final answer here. Okay, so my final answer is I should have 1 water and I have an iodine. My electrons canceled out, my hydrogen canceled out. I've got 5 hypochlorite ions. Okay, on the right I've got 2 iodate ions. I've got 2 H pluses. My electrons canceled out. I've got 5 chloride ions, and then my water's all canceled out. Then you want to stop and double check and say, well, is this reaction really balanced? Okay, so let's check your H's first. I got 2 H's over here, 2 H's over here. I'm good. I've got 1 plus 5. There are 6 O's on the left, and 2 times 3, there are 6 O's on the right. 2 I's here, 2 I's here. 5 chlorines here, 5 chlorines here. So my number of atoms are balanced. What's equally important, though, is to check to see that your charge is balanced. So on the left, these 2 things are neutral, and I've got 5 negatives. So over here, my charge is -5. Over here on the right, I've got 2 positives and 2 negatives. Those cancel each other out. And then I've got 5 negatives over here. So my charge on the right's -5. So my number of atoms are balanced, my charge is balanced, and that is your final check to make sure that you did the problem correctly. So there we go.